This is lesson 6, exercise 9G rather, Eulerian trails and circuits. So there are trails and circuits, and then there are specific trails and circuits that have special features, which are called Eulerian trails and Eulerian circuits. An Eulerian trail is a trail that includes every edge in a graph, and an Eulerian circuit is a special Eulerian trail that starts and finishes at the same vertex. So these will make sense once we get into specific examples. The rules for identifying Eulerian trails and circuits is as follows. Only traversable graphs, so what we learned in the previous exercise, can have an Eulerian trail or an Eulerian circuit. To have an Eulerian trail or an Eulerian circuit, a graph obviously must be connected. For the trail, to have the Eulerian trail but not an Eulerian circuit, the graph must have exactly two vertices of odd degree. An Eulerian trail will start at one of the odd vertices and finish at the other. And for the circuit, to have an Eulerian circuit, the graph must have all of the vertices of even degree. An Eulerian circuit starts and finishes at the same vertex. It can start at any vertex. Doesn't matter which one. So a graph with more than two odd vertices, or odd degree rather vertices, is not traversable, and as a consequence of this, it does not have an Eulerian trail or an Eulerian circuit. So these applications, in everyday life, these Eulerian trails and circuits relate to situations like a postman wants to deliver mail without traveling along any street more than once. A visitor to a tourist park wants to minimize the distance they walk to see all the attractions but not having to retrace their steps. A road inspector wants to inspect the roads linking several county towns without having to travel along each road more than once. This is one of many applications that you can have in the real world. I know a lot of truck deliveries, look into Eulerian trails and circuits. Even local artists that want to do their concerts and stuff, like travel on the road, and I want to visit certain places, to a very, very basic degree, will use Eulerian trails and circuits. So it does have real life applications. So for these examples, we're going to look at the same examples that we did in the previous lesson. But for each of the following graphs, we're going to determine whether the graph has an Eulerian trail, an Eulerian circuit, or neither, and we're going to say why. And if it does have an Eulerian trail or circuit, we're going to show and state one example. So there are different examples that we can get, but the most important thing is to determine whether it has an Eulerian trail or circuit. So the first one, all of the degrees are even. This is a circuit because we can start at any of these vertices and end at that same vertex. And because all of them are even degree, we can say that it is a circuit. So we can start here and go, or do that for any starting point for any vertex. In this case, it's a circuit. In this one here, even, and exactly two odds. Since it follows this characteristic, we will say that it's a trail because it has two odd vertices. So for this example, you got to remember that it will start at one of the odd vertex and finish at the other vertex. So if we want to start here, maybe we can go 1, 2, 3, 4, 5, 6. So it started here and ended there. And we can do that in reverse, starting here and ending there. So it always starts at one of the odd vertex and ends at the other odd vertex. Third example, because you have more than two odd degree vertices, it's not possible to create an Eulerian circuit or trail. And so there is no possible way of being able to do a circuit or trail with this graph because it doesn't meet the characteristics. This is the conclusion of this lesson, which is lesson 6, exercise 9G. Check your books, see what questions you need to do. I'm hoping that if you are watching these videos, that you should be finishing all the exercises and worksheets at the end or to the end of 9G. So by the time you get back to school next week, you'll be up to date and not falling too far behind. Until then, I will see you at the start of term 4. Study up and also enjoy your holidays while you can. Catch you soon.